the compass always points north. What happens if we get exactly where it's pointing? This one is by far the winner in a survey I did to find out what the best question was. And of course, because of that, it will be saved for the end. The sponsor of this video is our partner Atao, because together we simplify finances. And for that, we're making a really cool series of videos about how loans work, how to protect yourself from fraud, and how credit cards work. All these videos I mentioned are in a playlist down below. Okay, so let's go answer a question about budgeting. How can I control my spending without cutting out everything I like? It's not that I live in luxury, but I want to save money without giving up comfort. For us to start thinking about this, it's good to know the difference between luxury, comfort, and unnecessary spending. Luxury has to do with lifestyle, with showing off. You know, that $10,000 purse. It's something that's kind of meant to show other people that you can afford to buy it. So if you need to save money, the last thing you're going to do is buy a luxury item. Comfort is everything that makes our life better. So traveling during vacation, for example, or being able to enjoy something on the weekend are things that if you cut them out, you'll miss them. So the ideal thing is to plan well how you're going to cut back. So if you can spend a little on comfort, but less than you would like, you can take a cheaper trip. Instead of going out on the weekend to a super expensive place, you can invite your friends to your house, split the bill, and so on. You can still have comfort, but spend less. And there's the third thing I mentioned, which is unnecessary spending, which is basically money thrown away. For example, there's something here that I know some people here do. Subscribing to 50 different streaming services, but you only use 3 of them. There's one that you might use once a year, which you could just subscribe to for the month when you watch that series. It's basically throwing money away. Or you pay for super high quality internet, but you never play online. You hardly ever download anything. You only use half of it. You could use a cheaper plan. These things are usually the first ones you cut because they make absolutely no difference in your life. They won't change your comfort at all. Is it possible to produce feces in a laboratory? Have you ever heard of a fecal transplant? Talking about fecal transplants might sound really disgusting, but they do exist and they're important. In our intestines, we have a huge colony of bacteria, and they're not bacteria that are bad for us. Quite the opposite, actually. They're super important for digestion, for producing certain hormones, and there are even people studying the relationship between the gut and the brain and how bacteria can influence that. We used to call these organisms intestinal flora, but nowadays we call them gut microbiota. The problem is when there's some kind of imbalance with these bacteria, for example, a new one comes in, pushes out the others, and starts to harm you. Or you take a very strong antibiotic, which ends up killing most of these bacteria. And then, the way to restore balance is to borrow someone else's stool, which doesn't necessarily have to be from a family member or someone you're related to. Of course, that stool will go through a series of tests to make sure there are no dangerous diseases in it. That will be dissolved in water. It's specially prepared so it can be inserted into your body, usually through the place it should have come out from. It's amusing to discuss this, but the treatment is important. Okay? Look, here's a question that a lot of people sent in this time in the Atlantic Ocean. Along the imaginary line with the Pacific, there's a division of colors. Why is that? Why doesn't the Atlantic Ocean mix with the Pacific? Why don't the waters of the Pacific and Atlantic Oceans mix? We're dealing with a fake news story, a lie that's spreading across the internet. To start with, I just got back from Ushuaia, which is the city at the very southern tip of South America, where the Atlantic Ocean meets the Pacific Ocean. To begin with, this division between the oceans, what's the Pacific Ocean? What's the Atlantic? What's the Indian Ocean? What's the Arctic Ocean? These are divisions that humans invented. There's no wall there. There's no physical line. There's nothing actually separating one from the other. So we could easily say that it's all just one thing. It's the same water. If you start taking water out of one ocean, all the others will decrease too. That's how it works. But there are places that we say are more or less where the oceans meet. Right here, in the south of South America, it would be where the Pacific Ocean meets the Atlantic Ocean. And there are some places where this happens. Look, coming down here, right at the tip, we have a passage between the Atlantic and the Pacific called the Strait of Magellan. It has this name because in the early 1500s, Ferdinand Magellan, who was leading a fleet to sail around the world, needed to pass through here. He crossed this passage, and didn't go by the far south of South America. Tierra del Fuego is a large island split between Chile and Argentina, and to the south of it, there's another passage called the Beagle Channel. That's the one where I was in Ushuaia. I took a boat ride through that passage. And even further down, there's the gap between Antarctica and South America, which is called the Drake Passage, and that's really huge. It's not a tiny gap at all. It's about 800 kilometers. It's also called the Drake Passage. That place is really tough to cross by ship, okay? Because the weather there is terrible. There's a lot of wind, huge waves, storms, and it's extremely cold. But do you know one thing that's the same in the Atlantic and the Pacific in that region? So when you're there, you won't see any dividing line. No line in the water. There's no visible difference between them. When you look, it's unrelated to the meeting of the waters in Manaus, where you can clearly see the difference between the Rio Negro and Rio Solimões. There are indeed some differences between these oceans, but on average. So look, the Pacific Ocean is a little colder. The Atlantic Ocean is a little saltier, for example. Where they meet, there's already a lot of mixing. The area where they meet is very large. But I know there are a lot of people saying, wait a minute, hold on. I saw a picture where there's a difference. There's a kind of white water meeting a kind of blue water, and that's the meeting of the Atlantic Ocean with the Pacific Ocean. That photo going around on the internet does indeed show two bodies of water meeting. But it's the meeting of glacier water, fresh water, which comes down carrying a bit of the mountain. That's why it's very whitish, because of the minerals it carries. Meeting the ocean there in the Gulf of Alaska. So it's a photo that was taken in Alaska that people are saying is the meeting of the Atlantic Ocean with the Pacific Ocean. Who is a member of the channel, by the way, always leaves a question here for the members. He has already asked a few times if the bus has 2 seats on each side, plus an aisle in the middle, how does it fit in the same lane as a car? I went to do some research here, and I found out that there is a maximum width for vehicles in Brazil, which is 2 meters and 60 centimeters, right? There's the National Traffic Council that says a car can only drive on the street if it's at most 2 meters and 60 centimeters wide. If it's wider than that, it needs a special permit. That means our roads have to be prepared for vehicles that are 2 meters and 60 centimeters wide, which is really wide, okay? A bus might not be that wide, but a passenger car doesn't even come close to that. Just so you have an idea, the best-selling car in Brazil is the Fiat Strada, okay? It's 1 meter and 66 centimeters wide. So that means when you think about building a road, it has to be designed for cars that are 2 meters and 60 centimeters wide. And when a passenger car goes by, you can almost fit 2 of them side by side. In fact, the most modern roads in Brazil are even wider than that, okay? Each lane is about 3 meters and 50 centimeters wide. Iberê. Why is the calculator keyboard different from the phone keyboard? To be honest with you, I don't even know where the phone is on my cell phone anymore, because I don't use it anymore. I only call through WhatsApp now since I don't enjoy talking much. It's easier to write or send voice messages. Let's take a look. It's true. Look, on the phone it starts with 1, 2, 3, and on the calculator it's 7, 8, 9, 4, 5, 6, 1, 2, 3. But it doesn't make any sense, right? To start with, the push-button phone is actually newer than the calculator. Okay, the calculator already existed before. And there are 3 different theories for this change. The first theory says that when these push-button phones arrived around the 1950s, calculators had already existed for quite some time, and people who worked with calculators typed really fast. They were already very used to it. When they went to dial on the phone couldn't keep up with people dialing so fast. It was better if they dialed a little more slowly. And then people changed the order of the numbers to make it harder to dial than on the calculator. The second theory says that Bell Labs, back in the 1960s in the United States, when they were designing the phone keypad, did several experiments, including trying to put it in just 2 rows, making several different layouts. And this was the one people learned to use most easily. And there's another theory that also makes sense, which is that on the rotary phone. That is, the dial phone. It starts with 1 and ends with 0. So it goes from 1 to 9, and then there's the 0. And that's what people were inspired by when they made the keypad. It starts with 1 and ends with 0. Which of these 3 is true? Nobody knows for sure, but at least we can understand that there's a difference between a calculator keypad and a phone keypad. Does the microwave work normally with the glass broken, or without the glass working? It works like that. D. You may have noticed that opening the microwave door automatically turns it off if it's running. That's because there's a little switch inside. That makes it so the microphone never works with the door open. That's so the radiation doesn't get to you, okay? So you don't get cooked a little bit when you open the microwave door. So it's likely that if you hit the glass with a baseball without breaking the door, the microwave will keep working even with the glass broken. But here's the thing, it's not the glass that protects you from the microwave radiation. It's a metal mesh that's next to the glass. If you look closely, there's a perforated mesh there, and those holes are the right size to prevent the waves inside from getting through. The waves are too big to pass through those holes, so it's them that protect you from the microwaves. Which means that even if you break the glass, but the mesh is still intact, you're still protected. This one came up in the research we did. Congratulations on the work. Please avoid using the word like, okay? Stanley cups preserve temperature with vacuum insulation. Why don't firefighter uniforms use this kind of technology? The Stanley cup, and like all the other cups that, keep what's inside at the same temperature. They have 2 layers, one internal and one external. And between these 2 layers, there will be like an empty space, a vacuum. The fact that it's empty makes it so that the liquid inside can't exchange heat with the outside. It's like what happens with a thermos bottle. And this creates a very efficient barrier to preserve the temperature of the liquid inside. That's why we can keep a beer cold in there for several hours, which, by the way, deserves a test on Manual do Mundo, right? But why don't firefighters use this? Then, because the cup is extremely rigid, it's hard. And then, if you were to use armor where you have a vacuum between your skin and the outer part, you would need something like a Stanley cup, extremely rigid, with an inner layer. You would turn into like a medieval knight. And if you look at a firefighter's suit, it's like really heavy. It's not the most comfortable thing in the world to wear, but it gives you a lot of mobility. We put it on. Once Mari put it on when we went to the fire department. And then there was another video where I tested flame-resistant fabric, and I wore it too. It's like it gets really hot, but you can run with it. For example, which you couldn't do very easily with armor made of Stanley cups. Now, answering the previous question, I don't know if I really use the word like that much. Now, I used it just to mess around, but it's a linguistic crutch. What does that mean? When you don't have much to say, when you're thinking in the middle of a sentence, you put like in. So today I went home and I found something and all these likes are useless. But if I say that the Stanley cup is like a thermos, that word actually has value there. I'm saying it's similar to a thermos. Well, similar to a thermos, that it resembles a thermos, or that it somehow works in a way similar to a thermos. In other words, should only be annoying when it's used as a linguistic crutch. When it actually serves a purpose, sorry, but I'm going to keep saying why does sunlight through a magnifying glass create a laser and fire? Does it increase the temperature? Why? The magnifying glass doesn't create a laser, okay? With a laser, you have a type of light where the rays travel in a straight line. That's why you can point it so far, because they don't spread out, they don't open up. With the magnifying glass, pretty much the opposite happens. Sunlight comes almost in a straight line. When it hits the magnifying glass, those rays get concentrated. You can make them go to a single point, and that's why it burns. You're putting a lot of energy, a lot of light, in just one. It's very similar to what happens with a knife, for example. To cut something, you put pressure on top of the object. The knife concentrates the pressure on a single line underneath. It's a lot of pressure, focused in just one place, and that's why you can cut. If money is made of paper, why doesn't the government just print more money for the people? It would be a very simple solution, and I won't say there aren't governments that do it, because there are. There are quite a few governments that do it, but it causes a big problem, which is inflation. Imagine you live on a planet where there are only 2 things you can buy. Okay, these 2 cell phones. That's all you can buy on that planet. So there are only these 2 cell phones, and all the money circulating on that planet is 20 Rias. How much do you think each cell phone will cost? Obviously, each cell phone will cost just 10 Rias. It can't work any other way. Because raising the price means there's no money to buy it. If you lower the price of the cell phone, there won't be any more cell phones to buy. So it all adds up for each cell phone. Now, what if I print 20 more Rias? What's going to happen? The price of the cell phone will double. It will get more expensive because there's more money circulating, but you didn't make more cell phones. The cell phone that used to cost 10 Rias will now cost 20 Rias with 100% inflation. This will also happen in countries if you keep printing money without control, if the economy isn't growing. So We have to be very careful with printing money so it doesn't cause inflation. Why do we have to look serious in ID photos? There's no law about it, but you've likely heard it before. Perhaps from the person taking your photo for the document, because it makes sense. After all, what's the purpose of a photo on an ID? It's so someone can take your document, look at your face, and see if your face matches the photo on the document. Now, if you take a photo smiling, what's the chance you'll actually be smiling when you arrive? I don't know, at a border, or at a bank, or something like that. The person looks at your document, and there you are. The ideal is to have a relaxed face, with your face still, in its natural position, without any expression, without making any kind of face, because that will make it easier to identify you. This question here is really good. I've wondered this before, and the answer is interesting. If I were in zero gravity, would I be able to bench press a ton? Lift the weight with my finger. Bench press, for those who don't work out, is that exercise where you lie on a bench, you put the bar here, and you lift the bar up. It's one of the exercises where we can lift the most weight, but it's not close to a ton. When I bench press, I think I can do about 40 or 45 kilos at most. Some gym buffs might say, I don't use light weights, but let's get to the point. In physics, one key formula is this look. Force equals mass times acceleration. We calculate force in newtons. Newton is a unit of force, okay? You can convert it to kilograms for better understanding. Mass, it's going to be in kilograms, and acceleration is how much speed it gains, right? How much you can accelerate the object. So let's imagine a bench press situation on planet Earth. A person lifting a dumbbell of 1,000 kilos, 1 ton, with gravity of 10 meters per second squared, which is roughly the gravity we have here on planet Earth, rounding it up. So, what does 10 meters per second squared mean? If you're on top of a building and throw a stone for 1 second, that stone will be at a speed of 10 meters per second. After 2 seconds, it will be at 20 meters per second. In other words, every second, the speed increases by another 10. So with that gravity and that weight, the force the person has to exert, you just multiply one by the other. It's going to be 10,000 newtons. And what does 10,000 newtons mean? For us to know its equivalent in weight, it would be the same as 1,000 kilos. In other words, for you to lift 1,000 kilos, you have to exert a force equivalent to 1,000 kilos. It's kind of obvious, right? But what now? If you're inside a spaceship, where there is no sensation of gravity, how do we deal with this? There's no acceleration here. That acceleration will be determined by your force. So to start with, you'd have to brace yourself against something, right? With something fixed behind you, because if you're just floating there and you push a 1-ton object, you're the one who's going to be pushed backward. The object will barely move. The one who will move is you. But if your back is against the wall of the spaceship, which is a super heavy spaceship, and you're pushing a 1-ton object, then yes, if you apply a force of 500 newtons, which is about 50 kilograms, the mass here is 1,000. And the acceleration will be 0.5 meter per second squared. So, you take a weight of 1 ton, apply a force of 50 kilograms, you can move it. Yes, because now gravity isn't getting in your way anymore. What will happen is that the object will move very slowly. You can't make it accelerate super fast. The heavier it is, the harder it will be for you to accelerate it. Or the less force you apply, the less it will move. But it will move, yes. Why is rice our dietary staple? If we were colonized by Europeans who eat potatoes, there's something really interesting about this whole story. You know, I started researching why we eat rice, and then I found out that it's complicated to get that answer because the indigenous people here in Brazil were already cultivating some types of rice. In Africa, they were also cultivating some types of rice. So, yeah, the populations that came together to form Brazil were already eating rice. And not just them, but pretty much the whole world. Just so you have an idea, according to the Brazilian Agricultural Research Corporation, rice is a staple food in the diet of 2.7 billion people. That's about 1/3 of the entire world. With potatoes, something interesting happens. When the Europeans arrived here, they didn't eat potatoes. Do you know why? Because potatoes are native to the Americas. Potatoes are from the Andes. They discovered potatoes when they got here. And it was us, I don't know if I can say us, because it was more in Peru and so on. I don't know if Probably in Brazil, there weren't potatoes. But it was here, the people of the Americas, who taught the Europeans to eat potatoes. Not just potatoes, but also the most consumed vegetable in the whole world, which is corn, which originated in North America. And also, from America comes the plant that gives rise to one of the most consumed sweets in the world, which is chocolate. Cocoa is also from America. And then, I keep imagining how European cuisine must have been such a sad thing before the discovery of our continent. Or can you answer this for me? I'm a big fan of yours. Thank you. What is the little ball inside the spray paint can for? When I was a kid, I really wanted to hold the thing inside the spray can, but I couldn't open the spray can until one day I found out it was a marble. Actually, when we visited the marble factory on that Bora V episode, the owner told us that kids these days don't play with marbles anymore because to play with marbles, you usually need a bit of dirt, and so that market was practically bankrupt. He only hadn't closed the factory because he sold to spray can companies. And when I went to research this, I saw a video from Portugal where the guy opens the can, and inside there's not a marble, but a tiny steel ball, like it was taken from a bearing. And what's the function of this thing? Inside the spray can, we have a payload, which is the paint, right? That's what you really want to come out of the spray can. But you also need some gas to push that out, right? To force it to come out, which we call the propellant. Usually it's a flammable gas like propane or butane, the same ones used in stoves. Inside the can, high pressure turns them into a liquid. So, you're going to have a mixture of paint, propane, and butane. Well, not exactly a mix, because if you let that can sit, those two things can separate, and then when you press the can, it won't be so good. The paint that comes out won't be uniform. That's why it's important to shake the can first. And the little ball will really help those things mix together. What's the difference between sparkling water and hydrogen peroxide? After all, if it's hydrogen peroxide, it's water with oxygen gas in it, but that's not the case. The bubbles in sparkling water are carbon dioxide, okay? We've even done an experiment here on Manual do Mundo, showing how to make sparkling water at home. Then you cool the water a lot and shake it together with the carbon dioxide. It will dissolve in the water, the CO2 molecules will mix with the water there. And the gas is no longer visible. The moment you open the bottle, you start to see these bubbles appear because the carbon dioxide starts to concentrate and form bubbles. Hydrogen peroxide, however, is very different from that. It's not water with dissolved oxygen. It's water with a different molecule that maybe we shouldn't even call water. Water is H2O. Hydrogen peroxide is H2O2. In other words, it's water with an extra oxygen atom that can be released all at once if we add a salt called potassium iodide. And then we create our beloved elephant toothpaste. Are you going to release any more books from the O Grande Livro collection? If so, which ones? Did you notice that now we have some books here in the background? We have 4 big books. So the first one was science, then history, mathematics. And at the end of last year, we released the chemistry one. And yes, we're currently reviewing the big book of biology. These books are amazing. They're very well illustrated, and it's a lot of fun to learn with them. If you've never opened any of them, I suggest you start with the big book of science or the one on history, which are the easiest. The big book of chemistry, for example, has a lot of high school content, but I've seen several kids, aged 9 or 10, really enjoying it. Okay, how long did it take to get to Brazil? Coming from Portugal during the Age of Discovery, these great voyages happened at the end of the 1400s and the beginning of the 1500s, when Portugal and Spain set out to sea and practically mapped the entire world. It was during this time that Portugal managed to sail around Africa and reach the Indies. It was during this time that America was discovered, that Brazil was discovered, and soon after, they managed to sail around the world on the voyage of Ferdinand Magellan, which I mentioned a little while ago. But the first official voyage to Brazil, because there may have been some other voyages before, but not exactly to claim Brazil and say it belonged to Portugal. Yeah, that happened in 1500. So, Pedro Alvares Cabral left Lisbon on March 9 and arrived in Porto Seguro, here in Bahia, on April 22. It took 44 days. Why do hospitals and 24-hour pharmacies have doors if they never close? There are many reasons to have doors. Here's why. The first issue is real estate, kind of architectural, okay? Because usually these buildings don't belong to the pharmacy. The pharmacy doesn't own the building. It rents the building. That means that property can be used for other things. If the pharmacy closes, they might rent it to a shoe store, and then they'll need the door. Building a property without a door makes no sense, since you need a door during construction, so people don't just walk in and steal everything. There's also a business side to consider. It's open 24 hours today, but tomorrow it might stop being open 24 hours, and then you'll have to install a door. But there are still extreme events, which are things that happen very rarely, but they can happen. For example, if there's a mass robbery on the street recently in Cracolândia, Sao Paulo, people broke into a pharmacy and took everything. This might have been avoided if the door had been closed earlier, and now there have also been several extreme weather events happening. For example, storms, strong winds, flooding, and power outages that last a long time. The power outage happened because of those other things. You get it, right? But in all these cases, you'll need to close your store, even if it's a 24-hour business, because it won't be able to operate when this happens. And there's one more thing. LD. Very few places are actually open 24 hours. Most of them are open 24 hours a day. But if you try to buy something on December 25th or January 1st, I guarantee you'll find most of these places closed. My name is Alice. Hi, Alice. And I wanted to know how high a helium balloon can go. That's the kind of question that seems simple, right? But it's not simple at all. First of all, a balloon will never float up forever, because a helium balloon floats the same way something floats on water, okay? It has less density than air, so it keeps rising as long as the air is denser than it is. But the atmosphere keeps getting thinner and thinner with less and less air. So there will come a point up there where this balloon will stop rising because the density around it is equal to the density inside the balloon. And it will just stay there, not going up or down. But in practice, that never happens. When you fill a balloon here, you need pressure. You need to push the air into the balloon. In the end, when you tie the balloon, inside there's a pressure of 1 atmosphere, which is the same as the pressure outside, right? Actually, inside the balloon, there's a little bit more. If there wasn't more, when you pop the balloon, it wouldn't explode. So it's a little more pressurized. Atmospheric pressure is the weight that the air in the atmosphere is putting on us. It's pressing down on us, and we don't feel it, but it's there. As this balloon goes up, the pressure decreases. That means the pressure inside ends up being greater than the pressure outside, and the balloon will start to expand. You know, a balloon can't expand forever. So, on average, from what I've researched, a helium balloon, like those used at parties, will explode at an altitude of about 10 kilometers, which is also roughly the height at which commercial airplanes fly. Some balloons will go much higher. When we sent a capsule to the stratosphere, in that 5 million view video from Manuel do Mundo, we used a balloon that was kind of deflated. It was weak. Down here, it was all limp. That means that as it goes up, it has much more flexibility to expand. It can expand a lot more before it bursts. In fact, in the video, we can see the black sky. That means it went up so high that it's in a region where there's very little air. And then you can no longer see the phenomenon that causes the sky to be blue. What is the purpose of the slit on the side of a dog's snout? When this question came up, the first thing I did was type dog snout into Google because I didn't understand what this so-called slit was. And then I realized that I had never noticed that all dogs have open nostrils on the sides. There's a little hole in the front, but also a big slit on the side. The crazy thing is that I did some research and I couldn't find the name of this thing in Portuguese. I found something like nasal slit. In English, it's nose slit, but I did find out what it's for. When a human smells something, if I smell this phone, for example, I can only sense the smell while I'm inhaling, when I'm breathing the air in, and when I breathe the air out. If I stay close to the phone, I'll contaminate the phone with the smell of my breath, the air that's coming out. So, the air that's coming out gets in the way when I go to sniff again, when I try to smell it a second time, because it'll have the smell of the air I just exhaled. With dogs, this doesn't happen. First, dogs have an air reservoir inside that allows them to keep smelling, even when they're exhaling. And this side part, this slit on the side, is exactly so they can exhale air in a different place from where they're smelling. And more than that, the air they exhale can even help push the surrounding air toward what they're smelling, which improves their sense of smell. In other words, these animals practically have a superpower in their noses. Let's be honest, right? There's a person's name on the periodic table. I bet you don't know which one it is. I know which name you're thinking of, and I'll raise you one. There are way more names on the periodic table than you might think. There's a really cool website from IBGE that tells you how many people in Brazil have a certain name. This website was built based on data from 2010. Okay. It reflects data from 2010, but it's still really cool. We can get an idea of which names are the most popular and whether that name actually exists or not. So what did I do? I went to the periodic table and looked for names that sound like people's names. The names of chemical elements that have something to do with names. For example, Tulio. In Brazil, in 2010, there were 24,500 Tulios, 910 Laurencios, 379 Indios, 323 Francios, 269 Cesios, 263 Germanios, and 242 Ernios. The list is pretty long, right? I won't read out the whole list, so I don't get on your nerves. But there were even 50 Polonios. And of course, the name you were thinking of was Helio. And yes, it's the most popular of all. There were 137,000 Helios in Brazil, which is about 230 times the number of Iberés, which in this case was 592 in 2010. Iberê. Why can the mosquito transmit dengue, but not the AIDS virus? It's something to think about, right? Why does the mosquito transmit malaria, Zika virus, yellow fever, dengue? Why doesn't it transmit HIV? The first very important thing is that HIV, the AIDS virus, does not infect the mosquito. It doesn't enter the mosquito's body like yellow fever does. For example, this means the virus will only stay in the digestive tract of the insect. And mosquitoes infect us because when they insert I don't know what the little tube is called. Let's look it up, right? The proboscis. It's the injection needle that the mosquito puts into us when it's drawing blood. It injects saliva at that moment. So if HIV doesn't infect the mosquito's body, there's no HIV in the saliva. Another thing I've read a lot is that when a person has HIV, there isn't that much virus circulating in the blood. So when the mosquito bites, it's a tiny amount of blood with very little virus. And that's not enough to infect someone. The questions about the stick tower are here. I was looking forward to answering some things. How much did the stick tower weigh? Before we cut it, it weighed 20 kilos and had 17,000 sticks. I think that hasn't changed much, okay? Because we cut off a part that was light. It must have had about 18 kilos and 15,000 or 16,000 sticks when it was standing. And if you think about a tower that's 24 meters tall and about 18 kilos, it's extremely light. One person can carry the whole tower without much difficulty. And that's why the wind ended up knocking everything down in the end. To raise the tower, did you think about lifting it in an indoor gym to avoid the wind? The tower was originally 30 meters tall. That's about the same as a 10-story building. Now tell me, where am I supposed to find a gym that's as tall as a 10-story building? Maybe at NASA. I don't know. Why didn't you measure the stick tower when it was still lying down? That's a very good question that involves a bit of geometry. Look, here's the tower lying down, and here's the tower standing up. If we were to measure the tower lying down, you'd probably use a tape measure from this end to that one, right? Because that's the easiest way. It's closest to the ground and all that, but that's not the height of the tower. If you look at it standing up, you realize that the height is this right here. See, it runs through the tower's center, not its side. That means if you measure the side, you'll get a measurement that's a little longer, a bit bigger than if you actually measure the height. So with the tower lying down, you would have to run the tape measure through it until you reach the point where, theoretically, the tower touches the ground. But that spot is in the air. It doesn't actually exist. Because the tower has legs, it's hollow inside here. You would have to find an imaginary point to stretch the tape measure to in practice. That's almost impossible because the tower isn't completely hollow. At the tip, for example, it's just a little stick there. There's no way you could insert a tape measure to go exactly through its center. With that tower lying down there and a bit of geometry, you could calculate the height like that, right? Without having to run the tape measure through the middle. You could, but then there's another issue. The tower is flexible. That means that when it's standing up, its legs, for example, could spread out a little, or the sticks could settle in a way that makes it shorter standing up than when it's lying down. So to make sure we're not cheating, that we're not being favored by a different way of measuring, the right thing is to measure the tower standing up. Breaking a world record isn't easy. Here's an email comment. To raise the tower, you struggled with the tower collapsing due to lack of attention. You just needed to tie the tower to a sturdier support with a giant iron rod the same length as the tower. Then you would hoist the entire set, including the iron rod and tower support. And when it was standing, you would remove the support rod, and what would be left was the tower standing. Unless that action is prohibited by the Guinness rules, you guys suffered a lot for no reason. No, that action wasn't prohibited, and we thought a lot about it. Come on. The first thing you must have noticed is that when something is very long, it becomes extremely flexible. So, if we took rebar, no matter how thick it was, and stretched it out over 30 meters, it would get as soft as cooked spaghetti. So, it couldn't just be a simple iron rod, it would have to be an iron tower. But it had to be a tower the same length we needed, that is, 30 meters, an iron tower, 30 meters high. Now imagine the price of that, how we would carry it, the danger of it. Putting something like that up, and it falling on someone, all the difficulties, all the logistics, right? Much heavier to lift, harder to bring to a stop. Up there, people holding it with the stilts. If it slips, it could fall on someone else's head. Anyway, it would be much more expensive and much harder to do. Building this tower here would take us about 3 times longer. And it couldn't really be made out of another material either, because a 30-meter tall wooden tower might actually be even heavier than an iron tower, since it would need more material, and even with the technology, we don't know how to do it. It wasn't due to lack of attention. We just didn't think it was a good option. But let's get to the key question. The golden question that won by far in our survey. What happens if we go to the North Pole with a compass? What would this segment be without this globe, huh? Before anything else, there's a difference between the geographic poles and the magnetic poles. The geographic pole is this point right here, okay? It's where the axis of this spinning globe is. It's where the imaginary axis of planet Earth would be as it spins. But the compass doesn't point exactly there. Our planet works like a giant magnet. That's why we use a compass. But the poles of this magnet, the ends of this magnet, are a bit shifted compared to the geographic poles, okay? They're a little off. And even worse, they move over time and can even flip. But there hasn't been any recent reversal, okay? All these voyages we talked about in this video, we're done with the North Pole pretty much where it is now. To understand the compass, we need to look at Earth's magnetic field. You've likely seen a drawing of a magnet with lines around it. These lines show how another magnet would align if it got close to it. So, if the magnet comes here, it will align like this. If the magnet comes up here, it will align like this. If the magnet comes near here, it will align like this. A compass is nothing more than a small magnet, right? So, this here is planet Earth, and the magnetic field lines are actually more or less like this. That's why if you put a compass here in the equatorial region, it will point north and south. It will stay aligned between north and south. But what if you put the compass up here? That's right. If we put the compass very close to where these lines meet, it will point to the ground. It will want to go down, but a compass needle can't point to the ground. It'll get kind of crazy. I saw a video of a guy who showed a compass working in Antarctica, and in practice it didn't work. Every time he moved the compass, the needle ended up pointing somewhere else. In other words, if you're very close to the poles, you can't navigate using a compass, which at first didn't make much difference because people couldn't navigate to the poles. Guys, thank you so much from the bottom of my heart for sending so many questions like this. I keep learning nonstop as I work on these answers. Okay. And one important thing, there are a lot of questions coming in that I've already answered because there must be about 50 Iberê answers on the channel already. To solve this problem, we're breaking up all the questions and putting them one by one in separate videos on the Clips channel, okay? So, if you want to take a look there, you can find several questions by their titles, and each video answers just that one question. All right, take a look. The link is there.